For decades, managing data centers meant logging into isolated switches, one by one, and typing configuration commands line by line through an interface. But as modern applications scattered across servers, creating massive waves of internal east-west traffic, that improvised box-by-box approach started to buckle. You simply cannot scale an enterprise network when every adjustment requires touching dozens of separate devices. Cisco Application-Centric Infrastructure, or ACI, attacks this problem by completely stripping away the concept of the independent switch. To manage modern traffic loads, you have to stop treating your network as a collection of standalone hardware and start commanding it as a single, coordinated system. There is a persistent myth that ACI is standard Nexus switching with a convenient web interface layered on top. That is entirely false. ACI is 3 distinct layers operating simultaneously: physical hardware at the base, logical managed objects in the middle, and a policy dashboard at the top. The APIC controller is the engine, pushing your rules down through the logical framework to configure the hardware below. The APIC remains central to the fabric's daily life, housing every policy rule, every performance metric, and day 2 operations. Before you attempt to configure a single port, you have to view these hardware, logical, and controller layers as one indivisible entity. This schematic drawing outlines ACI's strict physical rules. Leafs must connect exclusively to spines. APIC controllers connect only to leafs. If you try to wire a leaf to a leaf or a spine to a spine, the system will actively reject it. This rigid architecture is intentional, a strict prerequisite allowing the fabric to automatically discover and map itself. When the system wakes up, protocols like LLDP and DHCP sweep through the hardware, verifying connections, assigning IP addresses, and sequentially registering every component. This automated sequence relies entirely on a few critical variables you define on day 1, specifically the tunnel endpoint pool and the infra VLAN. These underlying resource decisions dictate how the fabric communicates internally. If you assign overlapping IP spaces or incorrect VLAN IDs here, correcting them later is a deeply painful process. In ACI, physical reality strictly limits system behavior. Your initial cabling runs and underlay IP planning form the foundation of the entire network. ACI stores its configurations not in isolated text files, but within a massive hierarchical database called the Management Information Tree. Every setting exists as a managed object. By defining these object properties, the APIC translates your requirements into direct instructions for the physical switches. Whether clicking through the web dashboard, sending a script via REST API, or typing commands into the CLI, you are always interacting with this exact same central database. Grasping this object model strips away the mystery of the platform. ACI stops looking like a chaotic web of configuration wizards and reveals itself as a highly predictable database projecting policies directly onto hardware. For external devices like hypervisors, hosts, and routers to actually use this network, they need explicit permission to connect through a system of access policies. This animation demonstrates how building that connection requires a modular chain. You define a VLAN pool, attach it to a domain, link that domain to an Attachable Access Entity Profile, or AAEP, and finally map it all to specific interface profiles on the switch. It takes several steps, but perfectly separates the physical reality of how a server plugs in from the logical security and routing policies it will use once it is connected. Building the network through this modular chain allows the design to scale without friction. It transforms device connectivity from an improvised task into a repeatable, systematic process. For engineers accustomed to quick port channel commands, this multi-step object configuration and access policy chain can feel abstract and rigid. That is the core strategic trade-off of Cisco ACI. You accept a steeper learning curve up front to secure a cleaner, highly resilient operating environment down the line. Because everything is built on that object model, network automation becomes highly predictable. Every port, every policy, and every tenant is a defined element that can be perfectly controlled via API. And when something breaks, you no longer have to hunt through individual switch logs. Fault tracking, audit logs, and performance metrics are universally centralized within the APIC. Committing to Cisco ACI means letting go of isolated switch features. You are stepping up to command a single, predictable, and massively scalable fabric.